A system comprises different interconnected components that collectively perform a unified function. In Revit, these are primarily component families, also known as loadable families. So it is crucial to understand how to create and modify Revit families, as this will enable you to design functional and sustainable mechanical systems with the software. And that is this chapter's focus. In this video, we'll explore the essential considerations when creating mechanical families in Revit. So launch Revit and click the New Families button, and this will open your default family templates folder, metric or imperial depending on your location or region. So for this course, we'll be using metric. So I'll go to the English folder. And the first consideration when creating families in Revit is to decide if it's a 2D or 3D family. If it's a 2D family, is it a detailed item or an annotation family? Detailed items can be used instead of 3D components when the level of information needed is minimal. They are also used to add more detail to 3D families. On the other hand, annotation families are primarily for symbols and project annotations. And there's a folder for them containing such family templates as tags, section heads, level heads, and generic annotations, among others. Now, if it's a 3D family, that leads us to the second consideration, and that is the hosting method. What is the hosting method for the family? So there are three methods of hosting components in Revit. The first is level hosting, known as non-hosted components. So such components don't have any relationship per se with other elements or surfaces, but you can adjust their offsets to the host level in a project. This hosting method is ideal for mechanical equipment, which are typically the parent components in mechanical system. The second option is face hosting, also known as face hosted components. Such items attached to the face of the host geometry, be it vertical, horizontal, or sloping faces, or even work planes. So they adjust with the host surface, thus enhancing multidisciplinary coordination. And the primary advantage of this hosting method is that they don't get deleted when the host surface is no more. Instead, they become orphaned. So for example, the diffusers or the air terminals in this project host to the ceilings within the linked architectural model. So when you delete the hosts, I can unpin this and delete this linked architectural model or simply unlink it. When that host is no more, the air terminals or the diffusers are still in place. They don't get deleted. Instead, they become orphaned items. So with the reconcile hosting tool in Revit, you can go to the collaborate ribbon under coordinates panel. You can see this reconcile hosting tool which launches this interface here. So with this tool, you can keep track of all the items that have lost their hosts, and you can always pick new hosts for them. You can always select a non-hosted item or an orphan item, and you can always pick a new host from here. So this hosting method is ideal for terminal devices and components, which are typically the child components in mechanical systems, such as air terminals, sprinkler heads, and even such things as mechanical control devices that we have in this project. Then the third option is element hosting, and here the hosts are architectural elements like walls, floors, ceilings, and roofs. And the implication is that if the host item get deleted, they also get deleted. So typically you even have to host the item within the host model, like the architectural model. So bottom line is avoid this hosting option for MEP families because you don't have control over the hosts. Now, after deciding on the host method or the hosting method, the next consideration is the category. And this determines where a family falls within the family tree in the project and also the schedule category during quantification. So for example, when I select this air terminal here, you can see that the category is air terminal. When I pick this fan core unit, you can see that the category is mechanical equipment. Now, when I scroll through the project browser down to the family tree, you can see the respective categories. So the category of an element determines where it falls within this family tree. If I go to mechanical equipment here, you can see all the mechanical equipment I have in this project The same applies to when I want to generate scale of quantities. If I go to the view ribbon here, from the create panel, I can launch scale of quantities, and then you can see the same category. So if an element is categorized wrongly, that means the quantities will not generate the right numbers when needed. Now the good thing is that this consideration can be changed later, unlike the previous two. So to demonstrate that, I'll go back to the family templates folder, and then I'll start a new project with generic models. So I'll come here under generic model. You can see that you have different kind of hosting. You can see wall, roof, floor, ceiling, and whatnot. So avoid this architectural hosting methods. Instead, I'll choose generic model face based. Now when I open the family, I will launch the family category and parameters button from here, and then you can see that currently the category generic models. Now I can switch this to something more specific like an air terminal. The same applies to families that you get from manufacturers' websites or from anywhere on the internet. You can always switch the category in most cases to something more suitable to your project. Now beneath the categories, you also have the family parameters, and this change slightly depending on the category that you choose up here. Now these parameters here affect the family's behavior, which is the next consideration when creating or modifying families. So I'll quickly go through some of them. The first is cut with voids when loaded. So when you check this parameter, it cuts a void out of the host surface. But for MEP families, checking this parameter is usually unnecessary since the host surface is almost always in a linked file. So it not likely cuts a void out of a linked model. Then you have the part type, and this helps to specify the component type for categories with multiple types. So for an air terminal, there are no separate part types, but if I change it to say a duct fitting, you notice that you have multiple options from here to choose, which helps you to specify the kind of duct fitting you want to create. So I'll change it back to air terminals. Then the next you have here is the round connector dimension. You can either use diameter or use radius. So this parameter determines the default dimension parameter when dealing with connectors or pipes, for pipes or round ducts. So for this, we can just use radius for now. Then the next you have is this maintain annotation orientation. So you want to check this parameter here when you are dealing with face hosted elements with nested symbols, and this ensures that element symbols display the same on floor plans irrespective of the host orientation, be it vertical or horizontal. So to demonstrate this, I'll go into this project. When you look at this, you see some mechanical control devices. Some of them are sensors, some of them are thermostats and whatnot. Some are hosted to vertical dock surfaces, some of them are hosted to horizontal dock surfaces and whatnot. But irrespective of the orientation of the host, by the time you go to the floor plan, what you see is the symbol that have been nested into that family. Now, irrespective of the orientation of the host, these symbols will display the same, and that is because that parameter has been checked. So when I edit this family and go to the family category and parameters, you notice that that parameter is checked, and that is why the symbols maintain their orientation. Next, you have shared. So you check the shared parameter if you are nesting a family into another and you wish to scale it separately from the host family within your project. For example, you can find some plumbing fixtures where some of the component parts are nested families. So if you want to scale them separately from the host, then you check this shared parameter. Also, you can fill in the Omni class number for the components if necessary. And then you have the room calculation point. So you want to check this for situations where the components are not physically within the spaces in a project. And this allows you to modify the point to fall within the spaces to populate the necessary engineering information in the spaces. So let's say, for example, you have these mechanical control devices that are inside the ceiling voids for the ones that are hosted to ducts, and you want to actually account for them in the spaces, or you want to extract some engineering information depending on the type of family. I can check this room calculation point, then it will enable this. You can see the room calculation point here. Then I can go to say an elevation view and I can bring this down so that this point actually falls within the space, and with that, Revit sees this particular item as if it's within that particular space. So that's what this parameter is all about. Then when you go back here, you also see the hosting or the host. So the read-only status validates that you cannot change the hosting method, and that is why it's one of the first considerations when creating a family. Unlike category, you can't change the host of a family later. Again, the parameters differ a bit depending on the family category, but these are some of the most important ones that determine the behavior of Revit families and projects. These are the crucial considerations for starting a mechanical family. In this chapter, we'll create two families, one terminal component and one equipment.